Okay, we're going to continue with our look at economic exposure, and we're going to get into how we would measure economic exposure. A little bit technical. Hopefully you can handle it. You're senior finance majors for the most part, so nothing should be actually beyond your skill level, even if you do have some time left in finance. So I'll mention the key ideas, and you can always go and kind of look other places, look at other finance textbooks, or go on the internet to search some terms like covariance, what that means. So let's just jump into this, and we'll walk through it and look at some examples. You may need to watch them twice. You may need to slow them down. You're probably going to need to read your book and kind of follow along there as well. But let's just jump into it. In terms of measuring economic exposure, we need to recall that economic exposure refers to a couple of ideas. One is that changes in exchange rates can affect the competitive position of a firm and affect its cash flows. We looked at the competitive effect. We looked at the currency effect. So those both affect the cash flows that the firm is experiencing. And then secondly, changes in exchange rates can affect the values of a firm's liabilities and assets. And that's what we're going to look at in a little bit more detail now. For this exposition, the examples we're going to look at, we're considering values of assets and how they vary based on changes in exchange rates. So we need a few pieces of data. One is the possible states of the economy and the probability of each state. So when we look at this spreadsheet example, let's just jump over here real quick. Oh, I didn't label the states. But the different states of the economy could be things like a recession, a normal economy, and a booming economy, for instance. So we have three possible kind of states of the world that we can end up in, let's say 6 months or a year from now. And we're going to assign a probability to each of those. You can see that's going on right here. I don't want to get into the spreadsheet yet, so let's go back to the Word document. We want the possible states, and the value, so the probability of each, we're going to assume equally weighted. We want the value of the asset measured in the local currency for each state of the economy. So depending on what state of the economy we find ourselves in, the value of the assets may differ, right? So in terms of real estate, I think of, in a recession, real estate usually goes down in value. In a normal economy, it's kind of at its baseline. In a booming economy, real estate usually goes up. So in that case, the value of a real estate asset would be positively correlated with the strength of the economy. And so we need that value. Number three, we need the exchange rate in each state of the economy. And then lastly, from these, we can calculate the dollar value of the assets in each state of the economy. So we're doing the local currency, the exchange rate, and then we get the overall value in dollar terms. To measure the sensitivity, actually, I don't want to go there yet. Let's just go look at my first example over here. And we have a piece of, some asset. I was going to say a piece of property. This kind of follows the situation I was talking about just a minute ago. But regardless, we have an asset that has value that is lower in state A, let's say the depressed economy, normal in state B, the normal economy, and then it has a higher value in state C, perhaps it's the booming economy. And we have exchange rates that differ based on the different states of the economy. So $1.40, $1.50, $1.60, depending on the state. Finally, we can figure out the value of the asset in dollar terms in each of those states. So this is just the product of those two numbers. If it's worth 980 pounds in the down state, and the pound is worth $1.40 in the down state, then our asset is worth $1,372 in that down state. So in this case, look real quickly here, we've got pound prices and dollar prices that are positively correlated. So that means that the local price is varying positively with the exchange rate. One more way of saying that is as the exchange rate goes up, the value of the asset in local terms is going up. So again, positive correlation between the local prices and the exchange rate. So we're going to go back to the slideshow here and talk about how we're going to measure it before we get into showing that example of measuring it. So to measure it, we can determine the exposure coefficient. This is a beta. If you've and you should have had some sort of a regression class, a statistics class, where you talk about betas. We're going to find out what the covariance of the dollar value of the asset is with the exchange rate. Covariance, again, this is a term I'm not going to get into too much detail right now, but you can go and kind of search on your own to see what the technical definition of covariance is. But it's basically How does the dollar changing in value relate to the exchange rate changing in value? If we have a high correlation, there's going to be a high covariance. And so we're just measuring these in a mathematical way. What is the covariance, the statistical measure of how these things change with each other? We're going to divide that by the variance of the exchange rate, and that gives us a beta. So covariance divided by variance is the definition of a beta. So we're getting a beta, and we're going to call this thing the exposure coefficient. Let's talk about what that number is going to mean. We're going to get a number, and we need to interpret that number. So it's going to give us a beta that is scaled such that the value is an exposure in currency for a 1 unit change in the spot rate. And we'll, again, looking at the example, I think it'll flesh out what this means. Even better, this gives us a measure of the amount of currency risk that we face and the direction of the risk. And so we can use the result to kind of inform our hedging strategy. So by entering into the appropriate hedging strategy, we greatly reduce or even eliminate the economic risk faced by the firm. So let's look at, and actually this is all of the words we're going to have. We need to do this by example. So let's go back to our example that we started with. And we're, again, in this case one where our prices, the local prices, is positively correlated with the exchange rate. So we've got all of this stuff filled out, and now we can figure out what the covariance, the variance, and the beta is for this particular example. So covariance. Thankfully, there is a function in Excel called the covariance function. We're going to do the covariance of the population, actually, because we think we've captured the entirety of the population in these 3 states of the economy. We're not doing a sample here. This is population, again, beyond the scope of this particular discussion. But we're going to take the covariance of these 2 numbers, the spot rate and our dollar value. So that's the first measure. Then we're going to take the variance of the spot rate. If we divide these 2 things in this cell, we're going to get a beta. This would be the exposure coefficient, and in this case, it's 1700. And that tells us, by the way, that a 1 unit change in the spot rate is going to give us a $1,700 change in value. So this is a measure of the risk that we're facing, and it also tells us how we might hedge. Now, to see how this plays into the situation here, we've got $1,700 our exposure coefficient. So let's go over here now and assume that we sell a $1,700 forward contract at a rate of $1.50. That's the normal state that we're in. And let's just see what would happen by virtue of having this forward contract if these different states happen. So again, we're going to go back to the states, see what the value is, look at the exchange rate, look at the value of our forward contract, and see what the ending amount of our hedged position would have been. So in this example, again, we've got 980, 1,000, and 1,070. Those are the same numbers that we had over on the left. The exchange rates are the same for the different states. And so we have this unhedged position. Again, that's the same thing that was showing up over here. Now the forward contract, if we are in state A where the currency goes down, we're making 10 cents on every pound that we've hedged, that we've sold forward, right? We've sold it forward at about $1.50. It's down to $1.40. So we've made $170 on our forward contract. And so the value of our hedged position is going to be the sum of those 2 things. We've got $1,542 in value because we've hedged our position. In state B, there's no value to the hedge, right? It's we've sold forward at $1.50. The market is at $1.50, so the forward contract has no value, but our ending dollar value is $1,500. And then in state C, where the exchange rate goes up to $1.60, the dollar value is $1,712, but we've lost some money on our forward hedge. We take away 170 from that, and our ending value is 1542. Now, what I want you to notice is that our spread is considerably tighter here. The lowest thing we can end up with is 1500. The highest thing we can end up with is 1542. And if we take the weighted average of that, we're somewhere around 15, 12. But the big thing is that the variance, the spread of these numbers is dramatically reduced from these numbers over here. Right, we have all the way from 1372 to 1712. That's almost 350, 360 difference between those as opposed to 40. Now we can measure that difference with a variance. So watch what I do over here. I'm going to click on this cell, and it's a variance function, variance formula in Excel. And if I take the variance of those unhedged numbers, right? The three different states that we have. And because it's equally weighted, I can use this formula. My variance is 19,659, just a measure of the dispersion of those numbers. If I look at the variance of my hedge positions, on the other hand, I've only got a variance of 392. Now, by definition, what's happening is we've split up our variance into two components, the component that we have hedged away and the component that we can't get rid of, right? We're still left with some residual variance even after we've hedged this thing. By the way, I hope you noticed that we hedged exactly the amount of money, currency, that our beta indicated. That is the purpose, or kind of one of the interpretations of this beta, is by hedging that number, we can reduce our volatility, reduce our variance to the lowest point it can reach. I'm going to stop here because we've already reached 10 minutes. We're going to look at these other examples in the next video, and I'll see you then.